Hi, welcome to the Olympiad geometry. Let's continue our study on radical axis. Before we start, if you think this video is helpful, please click the like button, comment, share, or subscribe to the channel. Thank you. Here is a problem. DE are points on edge ABAC in triangle ABC. Prove center of triangle ABC is on the radical axis of the circles with diameter B and CD. You may find this problem is quite similar to the problem we solved in last video. So let me just draw the figure of this problem first, that we know we have a triangle ABC here, and D are arbitrary points on the line AB and line AC. So we want to prove that the center of triangle ABC is on the radical axis of the circles with diameter B and CD. Let's just refresh our memory of the last video problem. It was seen that in the triangle ABC, DE are points on the ABAC which make DE to be in parallel with BC, right? And we want to prove that the altitude AF is the radical axis of the circles with diameter DC and BE. And just quickly review the solution we provided in the last video. We found that the center of the circle with BE diameter is the midpoint of BE, and the center of the circle with the CD diameter is the midpoint of CD. So that O1, O2, because DE is in parallel with BC, so it's quite easy to prove that O1, O2 is in parallel with BC, which means the radical axis must be perpendicular with O1, O2, right? And in last video, we just proved the power of A with respect to O1, circle O1 and circle O2 are equal, which means AF, the altitude AF is a radical axis line, right? So for here, the problem is different. It's more like a general case that D and E are arbitrary points on the edge AB and AC. So sometimes we need to think about the problem like this. Maybe it looks like a more general case, but usually it's not that difficult compared to the original specific case, because sometimes you may just think the problem in another way. You can solve it. For example, in this problem, let's just find the center first, which we can draw the altitude from B to AC, right? So let's call it BF, and we can draw the altitude from C to edge AB. Let's call it CG. Because angle BFE is 90 degrees, that means F is on the circle with BE diameter, right? And also because angle CGD is 90 degrees, that means G is on the circle with CD diameter. And we know that the intersection point of BFCG is the center H, right? And the power of H with respect to the circle with BE diameter is BH times HF, right? Because you can think about it like this. This is a BE, that's a diameter. F is here. H is a point here, right? So the power of h with respect to the circle with diameter BE is BH times HF, and the power of h to the circle with CD diameter is GH times HC. So the question is that whether BH times HF equals to GH times HC, right? If these two power the production are equal, that means H is on the radical axis. Now it's fairly simple to prove because the triangle, in triangle GBH and triangle FCH, they have the angle GHB equals to angle FHC, and they are right triangles. So the triangle GBH is similar to triangle FCH, which means GH to HF equals to BH to HC, which means BH times HF equals to GH times HC, right? That demonstrates H is on the radical axis. And so, because this, the author center is on the radical axis, we can just use this conclusion, simply give another solution for the problem in last video, which in last video that the radical axis must be perpendicular with O1, O2. And we already know it passing through the author center H. That means the altitude AF is a radical axis. Okay, that's it. This problem is more like a general case for the problem we showed last video. If you figure out how to do the auxiliary lines, it wouldn't be a very difficult problem. I hope you like this video. See you in next one. Thank you.